Alright, now someone has taken the trouble to send in some queries with regard to the topic on sampling methods, and I thought this video would be a good opportunity or platform for us to share some queries with regard to this topic. Let us take a look at what this student is asking. Now, for tutorial question number 3, assuming that each household only has 2 adults, would the sample still be deemed as random? Our short answer is yes. But before we move on, let us take a look at what is meant by a random sample. What is meant by the keyword random? Now, a sample is random if and only if every member of the underlying population of interest has an equal chance of being selected as part of this sample. Note the key idea behind what is meant by a random sample. Everyone in the underlying population needs to have an equal chance of being selected. So now, if we take a look at the context of this question to understand this situation more clearly, in fact, this would be question number 2 of our sampling methods tutorial. We require a random sample of 200 adults to be selected from a particular residential section of a city. Now, in the later part of this question, there's one suggested method which consists of 2 stages. The first stage of which is to select 200 households at random. Okay, there may be 1,000 households, for example, and we're selecting 200 households at random, so every household has a random chance of being selected. Secondly, you're going to select 1 adult at random from each selected household. Let's say this household would have 2 adults. Then if this household is selected in the first place, each adult would have an equal chance, 50% each, of being selected. Now if this household has 5 adults, then each adult would have a 20% chance of being selected, but that is based on the event that the household is selected in the first place. Now, while in general, not every household would have the same number of adults, and as such, not every adult is equally likely to be selected. What happens if every household only consists of 2 adults? What would be the situation like? Now consider this hypothetical example in which we have the adults in a particular section of city. Now all these adults are making up the population of interest in this study. We have 2,000 adults in this particular section of the city, that's for example, and there are 1,000 households in this city. Each has 2 adults. Now the probability that a household is selected would be 200 households out of 1,000 households, which is 20%, and this is a constant for every household because these households are selected at random. The keyword is random, and therefore every household has an equal chance. Now we're going to rewrite all these households, give them a label, household number 1, household number 2, for convenience of argument, all the way up to household number 1,000. And now, with no loss of generality, let us just consider the 595th household. And there are 2 outcomes that are available, or 2 events, one of which is its selection, and its associated probability is 20%. Now 80% or 0.8 is associated with its non-selection, or in the event it's not selected. Now if it's selected, the members within this household, let's suppose we have Tom and Jane living in this household, and because each of these adults in this household would then have an equal chance of being selected, therefore each branch would have an associated probability of 0.5 or 50%. Now what is the overall probability that an adult is selected? For example, what's the overall probability that Tom will be selected in this selection scheme of 2 stages? First, we have to take a look at how likely this household is selected. That's 0.2, and in the event it's selected, if we choose Tom, then that would be 0.5 times 0.2, upon the probability that Tom is selected, and the resultant probability would therefore be 0.1 or 10%. Now the probability that Jane is selected would also be 10%, because that's just 0.2 multiplied by 0.5 to give us 0.1, 10%. If we take a look at other households, let's say we take a look at for example, the 703rd household, okay, it has the same structure. Its probability of selection is also 0.2. Its probability of non-selection is 0.8. Okay, let us take a look at this. And suppose we have two males this time living in this household, Harry and Thomas. Each would therefore have an equal chance, right, 50% of being selected, given that this household is selected in the first place. And the overall probability that each is selected would be 0.1 or 10%. Okay, and we could compare every adult in this section of the city, and because they live in a household that has two members, the resultant probability of being selected in this scheme of two stages would be 10%. And since everyone has an equal probability of being selected, okay, okay, and in general for every adult in the household of two adults, therefore, okay, everyone having an equal chance of being selected means that the eventual selection of 200 adults would constitute a random sample. Okay, and therefore our answer is a yes. Okay, our answer is a yes. But what if we tweak this problem slightly? Okay, and think of the situation in which one of the adults in the 1000th household decided to move in and stay with the family of the 999th household. Then that would still make a population of 2000 adults. Okay, let us take a look at this again. That will still make a population of 2000 adults in this section of the city. But in the 1000th household, because one adult moved over to the 999th household, we would have 3 adults in the 999th household, but we're left with 1 adult in the 1000th household. Now, would everyone have an equal chance of being selected? The answer is no. And to illustrate why, we could simply draw, right, a diagram, right, for the 999th household, right? Pardon my handwriting over here. And now if we take a look, its selection, right, the 999th household selection has a probability that is 0.2, because every of these 1000 households are selected with equal probability. Okay, it's the same, 0.2 or 20%, and its non-selection is associated with 80% of probability. Now in this household there would be 3 adults. Let's say the 3 adults who now stay in this household are named Allison, right, Alice, and Amy. 3 people. Okay, Amy is the person who just moved in. But if now there are 3 people in this household, then given that this household is selected, each of these individuals or each of these adults would have 1/3 chance of being selected. But the overall probability of, for example, Alice being selected in this selection scheme of 2 stages would be 0.2 multiplied with 1/3, right? The probability that Allison would be selected, given that the event that this household is selected in the first place, and the overall probability would be therefore 0.2 times 1/3, which is about 6.33%. Okay, or 1 out of 15. Okay, now how does that compare with other members in the same household? It's the same, right? Alice would also have a 1 out of 15 because 0.2 times 1/3, and Amy also have 0.2 times 1/3, 1 out of 15 chance of being selected. But does it mean that does every adult in this residential section have the same chance? Okay, now within this family everyone has the same chance, but if we just compare this value of 1/15 for that of Amy with 1 out of 10 or 10% chance for that of Thomas, for example, okay, then it is clear that not everyone in this city, right, not everyone in this residential section would have the same chance, right, because people, right, or adults in this 999th household would have a slimmer chance of being selected due to the fact that there are more people in the family. Okay, and therefore, if we tweak this problem a little bit, the answer is no, not everyone in the residential city would have an equal chance of being selected. But if we go back to the question that every household has 2 adults, then every adult will have a same chance of being selected.